If the number consists of more than 1 bits, means 2 bits, 3 bits, etc., then the weight of MSB is always even and power of 2. Sum of the rest of weights, means sum of the weights of those bits which are not most significant, is 1 less than the weight of the MSB. You can see here 2 to the power 3 has weight 8. But if we add 4 plus 2 plus 1, we will get 7. 7 is 1 less than 8. And this is true for any number of bits.
Here all the bits of this 4-bit binary integer are 1. If we treat this binary integer as unsigned, then we have to add the most significant bit with the sum of the rest of weights, and the decimal equivalent is 15. But if we treat the same integer as signed, then we have to subtract the weight of MSB from the sum of the rest of the weights, and we will get -1 as the decimal equivalent. It does not matter how long the binary integer is. It is 8-bit, 16-bit, 32-bit or 64-bit. If all the bits are 1 and we are treating the integer as signed, then the corresponding decimal equivalent is always -1. Because weight of the MSB is always 1 more than the sum of the weights of rest of bits. And the MSB is always going to be subtracted from the sum of rest of bits.
Here the ranges of different binary numbers are given in both signed and unsigned manners. If you treat the 8-bit integer as unsigned, then the range will be 0 to 255. And if you treat the same 8-bit number as signed, then the range will be -128 to 127. And this is the data for 16-bit, 32-bit, 64-bit, and finally in general, n-bit integers. The task for you is check all these data if they are correct or not.